Okay, we're live.
Assalamu alaikum. Uh, Good evening, everyone. And welcome to this new session of Morocco HPC webinars. Today we have the chance to have with us Bilal Hadri, who is the lead senior computational scientist at the Chaos Supercomputing Lab, where he oversees operational support and strategic procurement for the Shaheen systems and IBEX clusters. So, by the way, Shaheen 3 is listed among the top 20 supercomputers. I believe Bilal Hadri will talk about that. So he joined Coast in July 2013 and leads regression testing, benchmarking, performance optimization, and automated validation pipelines to ensure functional correctness and sustained performance across heterogeneous HPC and AI platforms. So Bilal Hadri has been appointed president of the Cray user group in 2026 for 2 years. Before that, he earned a master in applied mathematics and PhD in computer science from the University of Houston. And then he held a postdoc position at the University of Tennessee Innovative Computing Laboratory under Dr. Jacques Dongara and served as computational scientist at Oak Ridge National Laboratory. So today he will present his presentation is titled Regression Testing for HPC AI Systems, Ensuring Functionality and Performance Predictability. So without further ado, I give the floor to you, Dr. Bilal.
Thank you very much, Dr. Ahmed and Dr. Safar. Thank you very much for the invitation and the introduction. And it's a pleasure for me to be part of this Morocco HPC webinar series. And hopefully you will enjoy the minutes together. And indeed, today or tonight, depending where you are, so I'm going to present you about regression testing for HPC AI system. And so basically ensuring functionality and performance reproducibility. So what is regression testing? There are several definitions, but the most important thing, and I put it here in bold, is rerunning tests to ensure that previously developed and tested software will be executed as expected after a change or sometimes at any time or for performance and functionalities. And to know what will be, and if we get the expected outcome, there is no regression. Basically, you don't have a performance degradation or functionality that does not work. And if indeed, like probably like here, when you see like this nice cartoon, usually we get rid of a bug. Okay, we are happy, but then if we're not careful, we introduce more functionalities. Or if you know the game whack-a-mole, like you try to catch one and then you have all that pop up. And so why? Because in today's, like you have a lot of changes that are required testing, like for configuration changes, for software, to fix bugs, and you have hardware changes. So the purpose of regression testing is to ensure that changes, nothing such as mentioned above, do not have and introduce like new issues. So, and the regression suites tend to grow over the time. So you select more issue, you find it. But however, like we'll see over the time that you try to see what will be the appropriate minimum set of tests that is needed adequately. And you might think, why you do it only for HPC? But if you do the analogy to like cars, how many times you do maintenance to check how car they is? Or for example, if you take the plane, so you see like they do a lot of checks and tests before you go and fly because these equipment cost a lot. So you need to ensure they are functional and they are running as expected. This equipment costs a lot, and so failure is not an option. So, and to be honest, like this testing, like I have discovered it as I am part of this Cray user group. So it's like different sites all over the world that have like several systems, mainly Cray. And I have noticed like there were like for the last like 20 years, they have done a lot of efforts. And initially, it was mainly focused, as probably you know, on the acceptance test when they purchase like some new system, large scales or even small. They have a test, what we call of micro benchmark. And usually that was the main purpose. Like you have a performance metric that the vendor and then you try to get the same or expected performance. However, you have also like more than 12 years ago, like there was also some testing on the software to see how is the evolution. And in the last decades, like some of my colleagues at Oak Ridge also, like Ashley, we started this kind of discussion, like bird of further, even at 7 a.m. In the morning, and to try to bring together different sides to see what you are doing, because this is kind of something new, because the computer are becoming like more and more complex. So this is kind of a kickstart of discussion between like different sides, what we are doing. And over the decades, so there was like several like benchmark where we had even HPC testathon for the last couple of years, and that I colled with different colleagues like from Oak Ridge, from Posey, and also people at NICE like a month ago. And this effort like started also has been also shared at the supercomputing conference, where with my colleague like Veronica Melissa, we did it on large scale systems. We had even in some conferences like application level regression testing, there was even a run-up best paper. So the first BOF at supercomputing was initiated in 2017, and since that we had every year a BOF. And in 2023, we had a bigger committee, and we were able to do the first international workshop of HPC testing and evaluation of systems, tools, and software. And this is called HPC Test. And we still like have time. So for the 2026, for supercomputing, we are open. So feel free to try to submit your paper, and hopefully it will be accepted. And we look forward to seeing you in Chicago in November 2026. So there are our effort, and here like I'm going to share like more about our story here, where I am working at Chaos Supercomputing Lab. So if you know, like it is like a university that is located at the shore of the Red Sea, and so we are like international universities with many people from all over the world. And what is like unique is we have a university campus, and we are living near the university. So we are a small team. Sometimes, you know, when we have issue, people like we may meet them like at the shopping center or at the movie theater or at the golf. So we have to ensure that we provide the service as at a high level, and our users are very close to us, most of them. And here probably is too small like to see, and we have like a diverse workflow. So we are using like people are doing like some CFD, some climate, some chemistry, some geoscience. We have also like bioinformatics, computer science, AI, and so on. So we are supporting different workloads. So we have to ensure that our users are satisfied. They can run at expected like performance and functionalities. As Dr. Isam has presented, so Chaos, since its creation, like in 2009, it had a supercomputer. So we started in 2009 with the IBM Blue Gene P, that was ranked number 14. Then after some times, like in 2015, we had Shaheen 2, which is a Cray XC40 systems. And after a few years, so we had Shaheen 3. So we had two components. One that we procured in November 2023 and accepted, and it was ranked number 20. It is pure CPU. We have like close to 877,000 of cores of AMD Genoa cores. And then like 6 months ago, we finally got our Grace Hopper 2,800 GPUs. So we have a history. So we need to make sure that the hardware and software are functioning as expected. And so as I shared like earlier, like the supercomputer and the cluster are becoming more and more complex because it has so different hardware components. You have now tens of thousands of processors, either CPUs and GPUs, and you have a lot of memory chips, tens of kilometers of network cable, thousands of storage disks, hundreds of applications that you need to support. So all of it, you need to make sure that they are tightly connected, all working in synchronization. And so the performance of all components, you may be monitored, but you need to measure independently. And sometimes you may not be capable like to find the issue or to identify what's wrong. So if an application is performing not as expected, where is the issue? So it will take time. So that's why like the more that you collect data, the more experience you have, so you will be able like to detect the issue and resolve the issue, resolve and find the solution. So what is the motivation? So for many years, like the regression testing has been like just like a part of software usually, because it's good like to compute quite fast, but you need to have the correct result as expected. You reminded me like sometimes like a joke, like someone put in his resume, "I'm very fast in calculus," and the interviewer was quite surprised. Okay, yeah, why? No, no, I'm very fast. You can test me. Really? Okay. And then the interviewer said like, "What is 512 by 225?" And the new employee that he would like to be hired, he said quickly 128. But he said it's wrong. He said yes, but I told you I'm fast. I didn't tell you that I am correct. So you have to be careful. So this is not acceptable for the user. So you have to make sure that when you provide a solution, it needs to be not only fast, but to give the correct thing. Okay. So in the past, what people used to do, it was just a ad hoc, mainly by the sysadmin, and just basically to do srun hostname. Okay, it's working. Okay, guys, now the machine can be released. This is not robust, especially now today with more and more complicated. And so before it was, let's give the machine back to the user as soon as possible, so that, and then we'll deal with the complaints. Yes, if you have like only tens of the user, it's fine. But when you have like accounts over 500 or up to 1,000, this is not scalable. This is not acceptable. So why we do that? Because over time, the performance may decrease, and we'll see that. And some functionalities may not work. So you need to detect this issue early as possible. So and also like more users, so you have new workflow because each one has its own way to use a supercomputer or cluster. Also the viability of performance. So imagine that you have like many sites, like for example UMCSP. You have like some people using cloud, or some people are paying the services. So you need to make sure that you provide the service as expected. You cannot tell him like today a code stay like for 1 hour, and then later on, like after 2 months, it is like it will take 1 hour and a half. There is something wrong. Okay, so we need to adapt methodologies. So for the best practice, so that we make sure that you get the performance as expected, and so that you need to do like sometimes up to daily tests and not wait for maintenance. So this is what we call continuous regression testing. And so sometimes you need to build automatic tools for that. I give here now a pure example like of the motivation and a kind of history. I know it's bad, but this is how we got improved. So in the past, as I shared, we got like IBM. It was only managed by the admins. So they used to install the software, they manage it, and they do basically in the past srun, hostname, it's working, they test the storage is mounted, okay, it's good to go. But the performance was never improved. And so over time, we said, okay, yeah, my code is running slowly. Oh, but what was your reference data? So if you recall, the first definition that I shared is rerunning, so that you have a value that you know that what you have, so you can compare to today. You cannot just say today I would like to run a new workflow. You need to have reference data, so you can check with the vendor or the admin, say something is wrong, because before I was running this benchmark for 1 minute, and now it takes 2 minutes. There is some problem. So in Shaheen 2, in April 2025, we put in a clear regression proceeding, and it has been adopted. We sit down all together and we said, this is not acceptable, this is how we do. And what we did, we took what we call the site acceptance test. We have some benchmark that the vendor agreed, that everyone witnessed, and we pick up some of the tests that should not be long, and we run them. And we keep running them, and we collect the data. And this was managed by the sysadmin and in collaboration. So the sysadmin witness when there is a failure, we notify, and then that went well for like 7-8 years. But overall, to have like a better collaboration, we designed like tests that are more automatic, and also we had the vendor, the sysadmin, and application teams all together working hand to hands. So what is the goal? So as I said, is to implement and put in place strategy on system performance and functionalities for regression and monitoring and to avoid any disruption to the user. And the goal at the end is to have zero ticket. We don't want to have complaint from user, oh, it's not working, or there is an issue. And so what is the impact? People will be quite happy. You keep delivering the best services to the user. We follow also the best practice. As I mentioned, over 20 years ago, the big labs did this procedure. So this is like now a standard practice at all the site, whether big or small. Anyone who has delivering services to the user, this is kind of a new motto. And we can adapt the methodology, new approach, because also to maintain HPC resources, so you put a lot of investment. And especially now the cluster that anyone has, you don't manage them for 1 year or 2 years. So usually, it's for 5 years or more, like up to 10 years. So you need to make sure that at least your performance is not degraded at the time, or at least controlled. Also, what we see the impact is a better coordination between all the teams. And of course, if you increase the scientific product and people you ensure that the system is exploited at a full potential. And so that's why you make sure that the components stay reliable. You can play with the vendor SLA, so you can say, okay, if you face an issue of hardware that is failing, so you have the data, so you can replace it, part of your contract. So what we do, as I said, here earlier, it's mainly functionalities and performance, and also correctness at the stage. And so when we do it is normally at every planned maintenance, but also you try to do it continuously on the production with subset of tests. And we need to be methodological. So meaning you should not underestimate any small issue. You remember the snowball effect. Sometimes it's tiny, it's okay. No, because over time, small tiny things will go and big, and at the end, it will be very hard to fix it. Sometimes the changes, you might have to do it on the main production. But if you have what we call a TDS, which is a test and development system that is much smaller, a couple of nodes, so that you will be able to check before you hit a big problem into production with large scales. But also check the functionalities. And not only with synthetic, but also with real application, because your users are doing real application. So you need to make sure that their application can be taken in account. Last but not least, also what I put here, Slurm accounting. So, and we'll go more into details. So what should be the testing protocol? And here I want to iterate, document, and communicate with all the parties. If you don't have something written, or you do not communicate it with the vendor, or with the sysadmin, or with your team, and also with the user, it will not work. You need to check what are the component tests that you would like to test. Is it just basic functionalities? And what it should include many things. It's not only the scheduler, it's also your programming environment, and we'll see it. And you have what we call synthetic test. It is well known, some best practice for the compute, for the interconnect, and for the file system. And what is more important is also real application, because if your synthetic test fails, don't try to run your application, because the performance will be bad. But the opposite, it doesn't mean your synthetic tests are working perfectly that your application will work better, because the application will start at the same time the compute, the interconnect, and the file system. While when you do synthetic, you focus only at one at a time. So that's why sometimes you do methodology. You start with the compute node, because if you have very bad node, why you should continue? Take down this compute node that are weak or don't give you. And at the end also is iteration, as I said, not only iteration in terms of documenting, communicated, but also to resolve the issue. And based on your history or your experience, you know sometimes when you will be able to release a machine to the user if some problems are not critical, and you can fix them later on. And also make sure that when you have new functionalities, you test them. Here I give some, and I'm sorry for the the font, like apparently like there is a mismatch. So this is an example of test regarding some functionalities. So the connection is basic. Sometimes like you have several nodes. There might be some node, login node that does not work. Tunneling, promptness of the command file. So if you don't test like how long it takes to do like a small ls or event connecting, so probably the mounting is not done properly. Check the file access into all your file systems. Checking the compiler, or whatever you have, like the Cray, the Intel here I put, but GNU, commercial software, like can I run TotalView, Linaro, ANSYS? Yeah, because probably, or unless your license server is down, make sure. The availability, so make sure that all the queues are up and running and record the number of the node that is down, because you need to make sure that you don't start a cluster or supercomputer if you have like more than 50% of the node downs, then there is a problem. Also like to stress the scheduler by submitting a variety of jobs from one up to full size of the system. You measure, like you stress it, and you check all the policies and the accounting, because this is very important. Also the compiler said it, the libraries that you have, or that what you have by the vendors, or what you have installed. And checking that you have your database and so on working and so on. So here I gave like for Xeod, which is a database for the libraries. Darshan, it is for the IO, for the monitoring and characterization of IO files. So this is very important. Also for the performance. So you need to check what we call like synthetic benchmark. Node performance is very important. The HPL, as we saw, like this is a top 500. But you don't need to run entirely on the system, but you do it per node. So you know which node is bad. You do the stream, which is for stressing if there is any memory issue across all the nodes. You do what we call like test link to make sure that the whole interconnect is working. And last but not least, in terms of synthetic benchmark, the IO. So you make sure you stress the IO of reading and writing to make sure that you have the expected performance. And last but not least, the performance of and viability of the application. And here you try to mimic what in general you have as a workload. You will not be able to test everything. No, just a subset, and try, as we said earlier, the test should be quite small, like a few minutes, 10 minutes, that can be representative. Some of you are expert into CFD. You don't need to do the full iteration, thousands. No, tens of iteration to mimic like a read and write that are more than enough. And you do, like, for example, here I give an example, like we do VASP, WRF, some CFD application, and one of our benchmark Exagiostat from one node up to 1,000. And in general, at cost, it says like if we have no issue, regression testing when the machine is hand to us is take about 90 minutes. So as I said, you cannot test everything. It's impossible. And the system needs to be available to the user. So you need to find a balance when and what to test. So I understand like the system are getting larger and with more hardware and functionality. So you need to pick and choose, and especially the ones that are recurrent. What are the issues? Okay. Sometimes you may detect what are the new change of the compiler or of the software library. So time to time, try to read carefully the detailed release of the node, like Slurm. Okay, there might be some changes, so you need to be ready. And also, like for example, if you or your system administrator, you have find a bug, make sure that it has been fixed, tested, and make sure that if it can be released and adopted in the next release or not. Identify the root cause. This is very important because we tend to, when we find the issue, we try to blame the user always. No, this is his fault. Sometimes the file system or the network. Sometimes it's something else. So try to also, like from the user perception, it can be some random issue. Okay, how it is, it can be very hard to reproduce some issues. So does he has like customized environment and so on? So this is like where like at cost we are blessed, but I think like also our colleagues at UMCSP, when you are very close to a user, you can just sit down next to him and okay, show it to me. How we can fix your issue, how we can reproduce it. This is very important. So sometimes we should not blame the user, but by having a global vision, you will be able to detect quickly the issue. So in general, what is the outcome and benefits? You have a happy user. Okay, they might go and to acknowledge you in a paper. They might bring you like some nice cookies and so on. So make sure your user are important, because for the people who are managing supercomputer, this is your client. If you don't have user, you don't have a machine. The outcome when you don't have issues with the ticket when you release the system for the next 24 hours, it's a blessing. I recall at one time where the machine was released by inadvertence without the regression testing, like close to 10 years ago. We had over 80 emails of issues. Good luck to deal with that. While if we took, as I said, like a couple of hours, you will not have to deal with 80 emails of angry user and trying to understand why that code is not working and so on. Okay. So we improve also the user experience from the installation, better collaboration with all the teams. The performance, and usually you will keep the performance always good, except when your file system is, of course, when it is used, you cannot guarantee that. And this is kind of tricky part. When you have the history, you will be able to provide a more accurate data to the vendor. Look, in March, I have this data, it was performing like that. And when he ran the test, when after a year you have a very bad performance, you will be able to challenge them and replace the part that are failing. Also, like what we saw, the benefit that we started with Shaheen, and now we did it with the IBEX, with the cluster. So the methodology, you can adopt it even for your workstation, not workstation, but your servers. There are also what we have seen, we have learned how to do this regression. It was like more manually. Now we are going towards like more automatic. And we can do now also continuous regression, like because we can test it on the fly with the subsets of node that can be released at night and so on. And here what we could try to do, like this is what we do, like daily testing. Here I give some example where like, for example, like over 10 years ago, where we are testing the IOR. IOR is to test the file system in terms of read and write. So we had the performance that when we agreed the red dot, this is agreed like over 500 gigabyte per second that we had like a machine Shaheen 2. So you see like in December, we had 560, 553, we are quite happy. But then what happened? In September, it started to be low. Oh, 487. Is it critical? Probably not. So, you have to find what will be the balance so you can call like for issue with the vendor. Here, I just shared I said, okay, we have a performance diagram. Bilal, don't worry, it's not a big deal. Oh, a month later, it goes down more than 10%. Something is wrong. And indeed, after like some study and so on, we identify not only the machine was used a lot, but also we have seen some in the individual OST were not performing as expected, because some of them were close to 85% of capacity. So there were not a proper balance of the disk across all the OSTs. So later on, you see, we discuss with the vendor, we saw, look, you have a big difference, and immediately they fix it. So when you have historical value, you can demonstrate, okay, please fix. If you don't have that, believe me, it will go down, and then you will see the performance of your machine not going as expected. Also, I give you another example where this is the HPL. So we show like the performance per node. We had at that time on Shaheen 2 6,174 nodes, and you can see the nodes are performing quite reasonable. In general, from 928 gigaflop up to some thousand. But however, if you see in this area, you have a lot of nodes that are not performing good. So we discuss with the vendor what's going on, and then what we call they have to trim and to see like here perfectly more balanced, across all the nodes. And now it became our reference. So any node that is performing below this number, it needs to be trimmed or drained, and so they will have to fix it. Okay. And you see that sometimes in performance of application. Here I'm showing like spec FM or WARF, when we noticed some issues, and that was related to previously about the IO, because at that time the IO was not going well, and these two applications have a lot of IO dependencies. Also here, sometimes, as I shared, like we try to trim or to fix the node immediately. But one day, like I said, okay, which are not trying to find the right root cause of the issues. And so I put in purpose, I let the node performing, not performing as expected. Like here, this is for the Shaheen 3 AMD, and the performance should not be below 6.6 teraflop. And over time, I see like kind of a dromedary hump. Okay, I know like I am living like now in Saudi Arabia, and we should not see a hump. As you see like this previous slide, it should be a perfect one nice like kind of distributed. Here you can see like kind of it's a double hump. It's not the right way. And all we had to fix like 400 nodes that they have trimmed. In the beginning, what they used to do is just to reboot the node and it's fixed. But the root cause was there was like something going on with the kernel, and with the latest release, it was fixed. So sometimes that's why I said like we should not in hurry to fix the issue, because sometimes I will just reboot the machine and halas, it's fixed. No. And you will not identify the root cause. Sometimes you let it degrade, so you will have a global view. Then here you demonstrate there is something wrong. Okay? Same thing, and you see like when after the fix, you see like how you have a perfect after rebooting and trimming. This is what you are expected. And when I'm saying like here, for example, continuous monitoring, so you will need to have also a full picture like when you have some user. So here I wanted like to show you a user that this is this graph that you show, like this is Shaheen 3 CPU usage, and this is the energy that or the power that is used. So I think like if I'm reading correctly, it's close to 4 megawatt when it's at full potential. And we will have like kind of maintenance, and so all the nodes are draining. And so we asked we had like a couple of users that would like to do like a full scale run. I said, okay, you know what? Around like if I recall like the timing here, it was close to 6 a.m. And we told him, okay, start to run. And then we have been monitoring myself and my teams and also the vendor, and we are checking the performance. And so he was running, and we said, come on, your code is not running? Yeah, it's running, but you know, it's fixed it's blocked at IO. And indeed here we see the IO, you see like around like 7 a peak of IO, and then it should like last no more than 10 minutes, and then it should do the computing. But I told him something is not working. And thanks to the monitoring of the IO and with the power usage, we knew that his code at full scale has an issue. Then we told him, okay, you know what, we'll have a maintenance, fix your code because apparently you have an issue. And then later on, once you have resolved your software issue, we'll be able to provide you another windows of testing. So sometimes it's not the machine, it's a user code, but you have to show him all the proof in parallel, like about the IO, about the power energy, so to demonstrate. And sometimes you cannot offer that on the fly during production. And here we did just before the machine will be down in maintenance, early morning. So if he had demonstrated that his code can use the full capacity of the power and can scale well, we'll have given him a better, like once after the maintenance, a machine that is with no issues, so he can run his work. Also, like as I shared earlier, this is a shared responsibility between the vendor, the system architect, the software engineer, and the domain scientists. So, but what is important also, we have to agree what is a reference. And sometimes even when it comes to a disagreement, each one, like we understand, like for example, the domain scientist wants this metric and so on, but also some community. If you know, like this recently, this HPL mixed precision, where the whole community had an agreement, I would say, like it was, the lower precision was FP16, what was the reference. However, with the new recent GPU card, there were some institute and some vendor, they said, no, we wanted to use the FP8. And that created some confusion, which is the value that we should show. And for example, in our case, like we run the mixed precision for FP16, it was a 700 petaflop. However, the commitment for one of the vendor was over 900 petaflop. Why they claim the definition for them is in FP8. So the definition for them is different than ours and with the rules. So sometimes you have to be careful. And they I would say, performed with a lower precision, of course. So sometimes you need to make sure that, as I shared earlier, you document and you make sure that the unit is not, don't mention only the performance number, the unit, to make sure which one and how you do it, which precision, because now, as you know, we have a lot of precision, and not only FP64, 32, 38, up to down 4, and who knows if we are going to have FP2 and lower. Okay. So in conclusion, so set the reference, as I said, performance, the metric, and the test case. Keep all your historical values. And sometimes I said, like, keep it nice and calm. So fixing immediately, it will not identify the root cause. So as long it is not critical, you may keep the report for better analysis, as I shared with you when we fix for the AMD node. Regression testing needs to be coupled with monitoring. And also now there is new challenge because you have new workload from the AI community or non-traditional HPC user. And last but not least, now there is cybersecurity. So this is another big topic. Thank you all again. It was a pleasure. And now I'm open for the question.
Thank you very much, Bilal, for this nice presentation. It was very informative, so I learned so much things. So I have a couple of questions, but I will give the floor first to the attendees if they have any questions, and then I can maybe ask mine.
Please.
Do we have some questions? I don't think so. So, Safa, do you have any question?
Yes, I actually just typed in a question. I typed it from our account, but that's okay. So my question, also thank you very much first for this amazing presentation. It was really informative, as Imad said, and a lot of really relevant details that we needed to know, especially that you mentioned also how the user is involved and that the user needs always to be in the loop. Because at the end of the day, you said something that's really going to stick with me forever. It's like, no user, no machine. And if you care about the machine, then you need to care. Yeah, you need to also care about the scientists who are using the machine behind. My question was about, like, from an admin perspective or someone who's working on the machine, not really using the machine. Are there any common, like, tools or frameworks that we can use to help with the testing and the process overall?
Yes. So this is a very excellent question. So there are different tools. Like here, I did not share it here, but there are like many centers that have been that have developed. So mainly, like you have from there are some website that I can share it with you later on. Like if you go to the group, like I have shared earlier, like the HPC test. So we are gathering all the. If you click on the, probably I should have shared the link, but if you Google or HPC test, you will see, so this group, HPC test, what is it? Yes, HPC test, you go to the website and you will see all the different like presentation and so on, especially the latest one from Nice. We have different like sites that have shared not only the benchmark, but also the tools. So for example, now at CAS, we are using Reframe. So the Reframe is kind of set of tools that you can have like written tests in the back. So you can run all these tests automatically. You can have like also the setting from different sites of different tests. Like, as I said, like HPL is very easy. You can find it from the vendor or we can share with you. So you will see like for the memory, for the interconnect, for the IO, all of these are kind of shared in different sites. The goal of this community is to make sure like we are trying to build just one repo for everyone. So now you have to go from different tests, like you go to the Switzerland, you go to this CCS, you go to at Oak Ridge, you go to, for example, EPCC, the Edinburgh, people from NERSC, from Argonne Lab, from Livermore. So all the different sites, they have shared the GitHub, the tests that can be shared publicly.
Okay.
And if any site or someone needs like more details, we can share like this. In general, like some tests are public. Some of the application of the user are generally not shared because these are like more like in-house code and so on. But we can, like for example, like even the chemistry, there can be like some basic test, some benchmark. And over time, for the application, what we did, either they are from the SAT, the site acceptance test, or when we have detected a bug or an issue with the user, we ask him, is it okay if we put it in our regression testing? And sometimes they're very happy to collaborate.
Yeah. Okay, that makes perfect sense. Thank you very much.
And if you need, like, if anyone needs details, please they can contact me at any time.
Okay, thank you. Thank you very much.
Welcome.
Okay, thank you. So, are you done, Safa?
Oh, yeah, yes.
Yeah.
I
Okay,
mean, I
thank
might
you.
have another one later, but I'm done for now.
Yeah,
Okay, so
probably I cite like Reframe, I cite other site, but also Pavilion.
Yes.
It is quite interesting, like from, if I recall, from a US lab. Yes, Pavilion.
Okay.
okay. So thank you, Bilal. So Safa, you picked one of my questions, but I have another two questions. So, so my first question, so Bilal, so how you can be sure that users are using the supercomputer in optimal like manner, so that they don't waste resources? Since you know today we have big issue of energy and stuff like that. So
Yes, this is not an easy question and to answer. Let's be honest. You need to work closely with the user to know if it is optimal. There are few tools that you can check. For example, the energy can be a metric. So, like for example, this is what I shared, like in the latest example. If a user using like entire machine and you see here the power is quite low, there is something wrong in his workflow. Also, in the past, I have detected issues with some users that are not using the optimal libraries or from the vendors. I give the example of all these math libraries. I recall when I was even when I was working at Oak Ridge, this is the tool like I shared earlier, like it's called Xeold. And this is detecting all the libraries that the user are linking their code with. And in one of the code, like that was like 15 years ago, in one of the NSF machines, and then the user was using Netlib. I said, what's wrong? Netlib, okay, it is a math libraries, optimal, but they are not optimized to the machine. So basically, you are using libraries, but they are not at the optimal. You should use MKL, you should use like the ellipsi from Cray, or if you had at the time IBM, the ESOL. So you need to use a vendor optimized library. So this is one way. Another way is like some centers that have did the metric with the energy to try to see. But if your code is doing pure, let's say like a lot of IO, so it will not draw a lot of energy. So the first thing is to know what the user is doing. So you try to see first what kind of application. If you know the application is compute bound, memory bound, you will be able like, to find out. Also, how to ensure they're using efficiently is to characterize. Normally, like for example, for some code, you will know if he's under using his the compute node. For example, why he's using like hundreds of node, while you know, for example, it's a chemistry of chemistry code, so he just need like a handful up to 20, unless he's doing a large large atom simulations. So to answer quickly, you will need to spend a lot of time, and it's not one metric. So you will need to have not only the monitoring, but to characterization of his application.
Okay, thank you. So for example, for the first, like, if you new user like ask for so for an account in Shaheen, so like is there any limitation, resource limitation, number of nodes, stuff like that, or
Yes.
it
Yes.
depends on his experience, etc. Is it like that?
Yes. This is, for example, we have set a limit of number of nodes in the beginning. I give the example like for the GPU, the first limit is at 64. Once you have demonstrated that you can run more or your problem is more unbustling, we can give you like more nodes. On the CPU, we don't allow anyone to go beyond like 2000 nodes unless you have demonstrated that it's scaling. So you recall like my kind of last slide? So in his case, for this one, so this is like a part of a visualization tools that he wanted to run like with in coupling like a climate code, and he did test and he showed us that at from 128, 512, 1000 it was running well. I told him, okay, let's test at 2000 and 4000, and you see at 2000 it failed. So we said, okay, fix your code, and then later on we'll allow it. So for the GPU, for the CPU are more, I would say, easy, while on the GPU it's resources that cost a lot, but also like we know that there are a lot of people competing for that. We need the barrier is lower because some of the early user, they do not have yet the experience. There are some people who have already the experience. Yes, they can do it.
Okay, thank you. So so we saw how we don't do the same thing. So we like the limitation is the same for everyone. So if you, for example, if you have specific requests, so we can give you, we have some QoS, like large QoSs that we give for specific users, but yeah, but
Yeah.
it doesn't depend on the experience. صراحة مهم.
Yes.
So it's still not
So,
reaching.
for example, one time I have detected an issue with the user. We know they are doing chemistry. Why he's using like thousands of node, and then he did a mistake. So for him also, because otherwise he will consume all his core hours, which is not good. And then he's complaining why he's waiting lot of time in the queue. So sometimes it can be his mistake. It happened.
Yeah, we got the same thing with our users. So okay, my second question is, yeah, you talked about like the performance tools and how you can, for example, using HPL, IOR, etc. So, but you, as you might know, so the performance can vary from supercomputer to another one. So, and my question is, when we can say that we are doing good or bad, since we know that we cannot, there are some theoretical performance that maybe we need to check against, but we know that we cannot reach this theoretical performances. So in which like in each level or for example rates, we can say that we are doing good.
Yes. So the first thing is probably for someone who just bought a computer or like server cluster and so on, from 1 to hundreds, it's the same methodology that you have an agreement or what we call like kind of the contract or the RFP, what is expected performance by the vendor. So he said like, I will be able to run on this node 10, let's say teraflop. Let's say like a company, Bilal Inc., to not name. So he said like, yes, with this new Intel or AMD, I will be able to provide that. What you should do, that's why like it is very important. And here I don't put it here, but do not trust anyone who is telling you, because sometimes you might talk to commercial people and the goal is to sell. So I might put like more burden on us is to look for the truth. So the truth is not from someone said it or from Sheikh Google or Mufti ChatGPT. No, it is you go to the sources. So you go and talk to NVIDIA, you go and talk to AMD, you go and talk to Intel, and they will share with you the data. So you know if the vendor XYZ is exaggerating or underperforming sometimes. So he will not say some issue. I give you the example like now for the Turing. Turing now can, one Turing node, the AMD, can perform up to easily 13 teraflop, which is good. By more tuning, you can go a little bit higher. But if the vendor tell you like 11 for some type, while by reference 13, you may say, okay, this is not doing well. And the opposite, he should not tell you that it can perform at 15 teraflop, where you know the chip manufacturer cannot provide that. Okay, so this is when you buy. Let's say like later on, like you had this supercomputer cluster already. Now you wanted to start from scratch. The good news that most of these CPUs or GPUs, we know in average, very close the performance. Even from the time of Haswell, they are not has been. So you can get the performance and the community, you can find them. So this performance are known. So let's say for the HPL to be the number, you should be close to 90. Have them, then I would say like around 70% of the theoretical peak of the IO. For the network, this is tricky because you need to know exactly your architecture. And the best thing to do is probably to compare with similar system. I give you the example, like for example, for Shaheen 2, I was able to run similar test on another machine. It was kind of sister machine. And this helped me to detect that we had issue on our system in one of the links. And with the collaboration with other center, I was able to identify what was the problem and then the vendor fix it. So it's not like from one day like fix. It's a lot of iteration, patience, and hopefully over time we learn more and hopefully things will get improved.
Okay, inshallah. Okay,
Inshallah.
thank you, Bilal. Thank you.
You're welcome.
So maybe Safa has another question.
No, not really. Yeah. Everything was clear. Thank you again.
Thank you very much. It was a real pleasure, like being virtually with you. And again, like it was great. Like I met you like 6 months ago, so it was great. Like in supercomputing Africa and Morocco. And again, thank you for what you are doing. كما تقولوا شكرا بزاف. It was a real pleasure, and keep doing this kind of series. So this is a great initiative. Thank you for the invitation, and keep in touch, inshallah.
Thank you, Bilal. Thank you for the attendees. Yeah, see you next time, inshallah. Yeah.
Inshallah. And in advance, Eid Mubarak. Okay, take care, guys,
Mubarak. Yeah,
and have a nice
Mubarak.
weekend. Okay, bye-bye.
Bye.